Good morning, good afternoon, and good evening, and welcome to the Friday Talk Show with your host Rajiv Kulkarni on Global Electronics Platform. Yes, every Friday we bring this show exclusively for the electronics community who are interested in understanding and knowing what's happening there in the electronics manufacturing sector. So this happens every Friday at 9 a.m. Central Standard Time of United States, also which is 7:30 p.m. in the Indian Standard Time. So why I put Indian Standard Time as well in my poster in our YouTube link is because of the reason how India is growing. It's a very high-end growth market, and also a lot of electronics is happening in the Indian market sector. So in these episodes, we bring in the technology experts who are engaged in the design sector, in the process, in the manufacturing, in the supply chain, or also in the sales and marketing side, because anything and everything related to the electronics manufacturing matters as the electronics circuits starts getting more and more dense because of the technology advancement that we have on a day-to-day basis. The technology advancement is related to artificial intelligence or AI enabled the data center, which is the big buzzword these days, which is happening globally. Data center is definitely, I would say, beyond buzzword because a lot of data is being transmitted across and anywhere in the world, whether it's automotive, whether it's aerospace, whether it's defense, whether it's consumer electronics or smartphones. So more and more data when starts getting transmitted or received, you definitely have to have a very high power density circuits, which needs to be designed at a very cost effective small design circuits. When we talk about cost effective small design circuits, it's naturally not a cost effective, but we are adding more cost because you're talking about very high speed processors, very high speed integrated circuits, and where the chip manufacturers, they put a lot of efforts in designing such circuits to make it happen to the world. Okay, so that's the introduction of our global electronics. My name is Rajiv Kulkarni, and I work with the company Momentive Performance Material. We are highly engaged in manufacturing silicon-based dispensing material for the thermal management solutions. Today's guest we have, he has been on our show quite a few times because of his expertise in various sectors in the electronics manufacturing. So I try to bring him so that his wealth of knowledge can be shared among our electronics community. So today's topic is, why is the V model important for Ultra HDI PCB design 4.0? So we have done already 3 episodes on V model, and designing Ultra HDI PCBs present significant challenges due to their complexity. It can be routing congestion, high-end component density, and fine features lead to intricate routing challenges. Signal integrity issues, fine traces, high speeds, dense layouts can lead to impedance mismatches and crosstalk and reflections. Thermal management is definitely, as I mentioned, thermal management is very important in the electronics manufacturing, especially these days as more and more power handling capacity is required in the very small circuits. The ultra-fine features and advanced via structures demand highly precise fabrication techniques. So the V model addresses these challenges by integrating testing and verification parallel to each development phase, promoting early defect detection and a higher chances of success. Applying the V model to Ultra HDI PCB design, the V model consists of 2 arms, that is the verification, which is on the left arm for design and development, and the validation, which is the right arm for testing and integration. So let's welcome Mr. Ambaprasad, who is a veteran in the electronics design as well as in the processes in manufacturing, and he worked more than 4 decades in the electronics manufacturing sectors. He's based out in Bangalore, that is Silicon Valley of India, in Karnataka state in southern part of India, and carries wealth of experience in the electronics manufacturing. Welcome to the show, Mr. Ambaprasad. Good evening to you. How are you this evening?
Yeah, good. We had a long holiday session,
Okay.
quite a few training sessions. Yeah.
Excellent.
Both I gave training also, I got trained. Both happened.
Oh,
Yeah.
oh, that is excellent. That is absolutely brilliant because training is always again good because you're trying to um, teach people, you're trying to bring in more and more knowledge to the industry. So that's fantastic. So let's start our today's presentation, Mr. Ambaprasad. And before I start opening the slides, why don't you just talk about just introduction of what is V model, if you can just say a few words.
Yeah, this session, most likely we are going to cover. Actually, we started with the left arm of V.
Mhm.
Then we were supposed to go to bottom of V and then to the right arm of V. Then I thought, though it is theoretically that's the way it is done, I want to just turn that theory upside down. I want to go to right arm next, and we
Mhm.
are going to show that why even before we start the design, we should have our test procedures and testing plan ready, so that whatever we design, it can be tested. So that's the plan. But implementation, I'm going to cover it in a future, maybe a future sessions. Yeah, on the right arm, for every specification what we laid out on the left side, there will be a corresponding test or a validation plan. Sometimes the compliance also will be happening on the entire product, even on a multi-board system. So that's why it is important. Even before we start the design, we should know what we are going to design and what we are going to test. Now we can straight away go to page number 39. Then I'll be covering the right arm. Left arm we have covered. Go to
Okay.
page 39. 39, 39.
Yeah,
You're
yeah.
at almost at the end now.
Okay, okay. Just a second. I don't see here. I need to stop sharing. Then we can go to the page. Okay, so keep talking something because it's important for people to know about what V model is and
Open the slide, go to full slide mode. I'm able to see my slides, not an issue.
menu is
Or
there.
should I share my
No,
slides and cover?
no. I am already here. So let's start that and yeah, you continue that. I'm opening that slide of 39. Densification is from silicon to packages and PWB. Okay, just a second. Next time, I think it's better use share your slide because it becomes easy for you to open up and
Yeah,
talk.
now
Here you go.
it's screen sharing.
Yeah, here you
Double
go.
click for, yeah, fantastic. So, yeah, that's good. That's where we were supposed to be. So the whole game of densification started at the silicon. People went on reducing the node, and they went on packing more and more nodes into a device. So
Mhm.
almost we have a 50 year of data. This data is publicly available. It started, but it gave its own set of problems. We can see in the orange color number of thousands of transistors where they are reaching at 2020, and it's after 1990 it is growing exponentially. Then performance, the frequency is also keeping up. Then the now if you see all this put together puts too much of pressure on available power. The typical power watts, you can see it's almost also rising heavily, and now it is almost plateaued. Now, in fact, a data center will take as much power as a small town. I mean, that's what's really happening today. If you, especially in a data center on AI applications, it takes almost the power required to run a small town. Yeah. Go to the next page, please. So that sets the mode why the ultra high density. By end of the presentation today, I'm going to take you by surprise, telling that ultra high density is not restricted to PCBs alone. So that's what is happening. Yeah, right arm of the V model, whatever we design, we should be able to test it. So, and test means testing and validation. And
Correct.
even compliance. Finally, people want UL certification, EMI/EMC certification, signal integrity, power integrity, closure. So in the context of ultra high density, this phase is all about testing, integration, and proof of concept. What we thought we will do, we should, your NPI will be proof of concept. And if there are no glitches, you can hit the market immediately and or with a minor modification, and the product hits the road. Okay. Then that design rendered is ultra fine, high performance interconnects actually deliver. That's what we promised that it is going to do, and now it is a time it has to deliver. So this is where the validation phase comes in. Go to next slide, please. So we have over 10 slides. Maybe you can decide when we can go take a break. Not an issue.
No break.
Now
We'll just
the
go. We'll just go. No break today.
then we are going for example, unit level validation at the PCB level. So we use DRC closure, we use signal integrity, power integrity, reliability closure. So using tools which are available, fine, fair enough. Then we have digital twins. Then the most important, you can say, a differentiator is a micro via reliability. You need a cross-section analysis. You need via performance under thermal cycling and via fitting modeling. If vias fail, it's very catastrophic to the system. And then conductor integrity, because we are using a very fine, uh, thin traces and fine spacing also, less than 25 microns. Then we should be able to deliver the signals as well as the power. Okay, this is the requirement. Then we can go to the next page. So integrated testing, stacked via chains, validate the signal integrity across stacked and staggered micro vias under high speed condition, most likely 56 to 112 Gbps. People are also talking of 224 Gbps on the optics now. That's okay. The optical modules that they will do their own validation and come. But now, power integrity, measure IR drop and decoupling performance in ultra thin dielectric environments. Now, the gap between the dielectrics is less than or almost 2 mils. That's it. In that condition, there should not be any breakdown or voltage breakdown, or it should not get heated up. So that is very important. And under thermal cycling. So people may do HAST testing, they may do conditioning the coupons, and they do all this validation and come. And here, in fact, why I'm telling this is very important is when you manufacture a PCB, it's first about we take copper, the copper clad, whatever it is, and then we remove copper by etching. Then we do plating. Okay. Now plating is to maintain the connectivity. Now there are two problems here. There is plating integrity, mechanical as well electrical integrity of plating, as well as copper is highly prone for contamination and corrosion. So that the corrosion protection also is important, especially on the surface layers. So these two are very, very important. These two are interrelated. Yeah. So next slide, please.
Yeah, already.
Yeah, that's about at a PCB level. But at a system level validation, manufacturing defect analysis, use optical, automated optical inspection, X-ray inspection, uh, then in-circuit testing, then followed by functional testing. So functional testing is go, no-go test. If product passes functional testing, it can be shipped to the customer. Then if something doesn't work as planned, as promised, whatever the reason, do yield analysis, get all the coupons and statistical process control data from the PCB fabricator and assembler, And just there are two things which are very important: uh, time to volume and time to market. Uh, Time to market is very important at NPA stage, but when we go to time to volume, okay, proof of concept is proven in say 5 or 10 or 15 modules, but when we hit the production phase and we start producing in numbers, say 100,000 numbers, then probably there'll be a factory change. Then we should get the same performance as what we got in the NPI build. So this is very challenging. This is the very most critical phase of the product cycle.
Oh,
Then environmental qualification, subject boards to humidity, vibration, temperature extremes, especially critical for aerospace and military and medical applications. Yeah. So why write ARM V model matters most in Ultra HDI? In any design it matters, but in Ultra HDI it is more pronounced because of sub 50 micron features, fine pitch component lead geometries, and even fine pitch soldering geometries. The soldering is very less in volume. People may not even do soldering. They may go for a fusion bonding or wire bonding and things like that. Then maybe they may go for bumps. So this is very important. Laser drilled microwires, ultra thin dielectrics, and a combination of all of the above in the same package. That's why the last statement is very important.
all the above.
Uh, this matters the most in Ultra HDA because this demands a tight process control and robust validation. The right arm ensures that, the successful implementation of validation in the right arm ensures that simulations were not just optimistic guesses. We didn't make a simulation to make our bosses happy or whatever it is. Whatever we simulated, we are able to deliver. So this is the proof of pudding is in eating. So okay, that now we are, yeah, that's it. Then the design rules, the DRCs, the design rules are really translated into repeatable and reliable manufactured and assembled hardware. So this is very important. So PCBs behave differently. Bare PCB behaves differently. But when we put the components on solder and put the functional test, the traces may behave differently. So this is very important. And catch hidden defects before they become field failures. These are so important. So the digital twins, the simulations, in any simulation, there will be a corner case. People might have taken some compromises that should not manifest into a field failure.
Great.
Yeah, a perfectly captured uh, the results is the essence of the V model's right arm in the context of Ultra HDI design. It is an incredibly effective way to make the abstract concepts of unit. Unit means the IC, the integration at the PCB level, and a multiple board level, system level validation are tangible and easy to understand. The workflow highlights the critical importance of the dictum: prove it right at the first time. So, okay, there is no second time. Okay, it should be right at the first time. And with the features pushing the absolute limits of manufacturing, simply trusting a digital design, what the simulation we did is not enough. It has to be in real copper and epoxy. It has to work under vias. The rigor of physical testing ensures that the final product is not just a functional but also reliable and robust enough for the demanding environmental where Ultra HDA is used, especially in aerospace, military, and automotive. This is very, very important. Where human life depends on that. In aerospace and military and automotive, human life depends on that. Yeah, this is very much important. Yeah. Next slide, please. Yeah, maybe you can take a break. Then I will explain this is something totally new.
Okay. So here we go for the break, but just want to tell the audience that first of all, I should thank all of you for watching the show and supporting our channel on a regular basis. And please do continue subscribing the channel and also share the channel link with your colleagues and friends in the electronics community sector, because the global electronics, this particular platform is meant to have brought in the experts like today's guest. We have Mr. Ambaprasad, and who can share their expertise, who can share their knowledge, wealth of knowledge, so that it can benefit the young engineers out there in the process as well as in the manufacturing sector. We'll just run a small video on our break session, then we'll be right back. Good morning, good afternoon, good evening, and welcome to the Global Electronics Friday Talk Show with your host, Rajiv Kulkarni. Today's date is August 29th, 2025, and today, right now, the time is 9:25 a.m. Central Standard Time of United States. And so we bring this particular show every week, every Friday, to create some kind of awareness in the electronics manufacturing industry by bringing the expertise, by bringing the people who have experience in the electronics manufacturing sector. Today we have Mr. Ambaprasad, who is sharing his wealth of knowledge in the electronics manufacturing industry, and he has been in the industry for more than 4 decades. And today's topic we are covering is V model and its importance in the Ultra HDI PCB design. So let's continue our discussion, and I'm going to share the screen right now. Yes, Mr. Ambaprasad, here we are.
Yeah, yeah. So, uh, when we talk of densification, we are talking of Ultra HDI, which is restricted to, say, the PCB structure and maybe the OSAT structure. But parallelly, the densification is happening in power delivery also. So if you look at this, which is publicly available, uh, generally so far people delivered power horizontally. You put the socket, you put the voltage regulator module, and this is just a PCB. And you put power supply module over here and rectification here and put lot of decoupling. Power integrity gurus told if something fails, they say put more decoupling, more decoupling. And they went on putting. And now the question is how fast to deliver the power, and how to reduce the loop, and things not get heated up. So now we are talking of about something like in excess of a couple of hundred amperes at a GPU level. So this is where it is happening. This is a planar power supply where you put power supply surrounding the socket, the decoupling structure, power delivery network. And 2010, it was 106 watt. And by 2015, it became 225 watt. A particular GPU company projected this. And then by 2025, they're almost hitting 1000 watt
Hmm. So
by
as actually
2025.
what I mentioned earlier in the
So with this, you are reaching the limits of the planar power supply network delivery. So that's why people are going towards what is called as a vertical power delivery. If you go to the next slide, you will see the schematic of that. You can just go to next page. Yeah. This is a proof of concept where you put the entire, this is the On top, we see the actual XPU, GPU, CPU, or TPU, whatever it is. And then the pin assignment is in done such a way that it is very easy to deliver power from the backside. At the bottom of the PCB, we have the actual power supply module, and this is been also been purpose built. Generally, the company which does the processors will collaborate with the power supply companies. They come with a proper design pin out such a way that you just place it according to the way they told. Power gets delivered automatically. And then you can see there is a capacitor, and capacitors are sometimes put within the PCB structure also. And then you can see it is very easy to deliver instead of a large planes. It just delivers power vertically to the area of interest. Especially the core power supply goes directly from the power supply module output pins to the input pins. So you can see the sockets in the green color. There is a power and ground. It just goes directly. So this is not HDI. It is not Ultra HDI, but is a 3D integration which uses the concepts of HDI and Ultra HDI. So now it is there is no difference between Ultra HDI or heterogeneous packaging or uh, power densification. This is what is driving the industry. So this is here. You once you buy, decide to use a particular GPU or XPU or CPU, the socket also you have to buy from the same consortia. And again, the power supply also, they have a few collaborations. They come out with a reference design and it just plays as is. Right from the schematic up to the bill of material they support. Of course, we'll be using their own components, needless to say. But yeah, it works. It straight away it works actually. Life has become simple. Go to next page, please.
Oh, that's it.
This is the last one.
Yeah, this is the last one.
Are you sure? Okay.
Yeah.
Yeah. So with that, what I was telling is uh, Ultra HDI and all these dense, there is no, they are not watertight. They are the one and the same. People call by different names. And now, maybe in the next episodes, we go back to the actual implementation, how it is done, because there I can share a lot of pictures and schematics and the schemes, how it comes. There is also, I'm going to talk about, I mean, we have heard of a design for manufacturability, design for assembly. Now there is called as design for fungible I
Okay.
mean, factors, where you take like a Lego blocks, you do in one design, you can replicate in another design. So these are another new concept. And also I'm going to talk about if you go to vias, microvia structures, if it fails, there is a mode called as a dimple. A dimple forms in the via structure. This is a failure mode. People are realizing now. I mean, when 5 years back somebody said dimple, we laughed at it, but now it is becoming a reality. So dimples
Yes.
are coming. So there are ways and means of avoiding that. So very exciting time ahead. Uh, Conclusion, I would like to say three sentences. The AI is picking up. If you are doing business of AI, great future. And AI goes along with power supplies and memories. So these three triangulation, power supply design, memory design, and AI. So,
Yeah.
and again, AI aids in design and assembly. Of course, still many OEMs are not getting into AI for their simulation and all, because there is a threat of IP sharing. But at least signal integrity, power integrity, people are already doing it. AI, AI-based DFM, AI-based copper balancing. Very recently, it has come. One company has it does a copper balancing. You do the copper balancing at the OEM at your premises, not by the PCB vendor. You do at your
Oh,
premises. If PCB vendor says this is not working, you just change a few fields and it gives whatever it wants. So that's very exciting. And then yeah, the dimple I covered about dimple. So it's no, it's a very exciting time. So maybe, yeah, thanks for the audience. Thanks for accommodating me in this class. In fact, last week I attended 4-day session for on AI in data center integration only, data center packaging. A lot of things have been learned. Yeah, that's good. Exciting times ahead. If you
Excellent.
are in with AI, either you are using AI or you are designing for AI, great future.
Excellent, excellent. Thank you very much, Mr.
Yeah.
Ambaprasad, for those very informative session of today. Why V model is important in the ultra high PCB design, which is 4.0, which was the episode. And next week we again bring Ambaprasad and with another topic, and we will publish that pretty soon. And then please do attend and please do log in and please do share our link and ask your colleagues, your friends to subscribe our channel so that the more the viewers, it's better for our guests. So there are a lot of sessions, lot of episodes are lined up with different topics, and every week we try to bring in a new topic which is beneficial for the engineers out there, the young engineers, the process, the design, the manufacturing, or the program management. You take any department in the electronics manufacturing sector. With that said, your host will take a leave for today's episode. And wherever you are, whichever part of the world you are watching this, please take good care of your health. As the elders say, health is wealth. And if health is there, everything is there. So please do take care of your health and God bless. Have a wonderful weekend. And we'll see you next week at the same time. Thank you very much. Bye now. Thank you, Mr. Amapasad.
Thank you.